What's up, guys? Back at it after your long weekend. Um, we're going to keep going with Learning Target 5 here. We're going to part B or part 2, whatever you want to call it. Use Q equals MCAT to calculate heat transfer during physical changes. Okay, so physical changes, we're primarily going to talk about water and that. Okay, so here's a water phase change graph. So let me just put this in perspective. There's some main points, right? That's when water is ice, and we know that ice is at 0 degrees Celsius. And then this is when water is going from a liquid to a gas. Okay, so you have ice on this slope. Okay, it's melting, going when it's flat. It's a liquid, you're heating the liquid up to 100 degrees. It's flat when it's phase changing, and then it's above 100 degrees. So moral of the story is this: when you're undergoing a phase change, the temperature doesn't change. So when the ice is just coming off the lakes in Minnesota right now, that water just stays the same. But it's all the ice has to be gone for it to actually heat the liquid up. So that's an example that you can relate to. And then when we get to 100, okay, well, when you have a thing of water and you're boiling it, well, it's going to stay at 100 degrees no matter what until all the water's gone. And then once all the water's gone, you can proceed to heat that gas, heat that steam, and you can get steam hotter than 100 degrees Celsius. So there's just some things that we need to know during a temperature change. Okay, we use Q equals MCAT. Okay, during a phase change, we use Q equals what we call the mass, whatever it is, times the heat of fusion, or Q equals the M heat of vaporization. So let's go back. During a temp change, the slopes are what we call temp changes. We're changing the temperature of the solid. Okay, the flats are what we call phase changes. All right. So if you have, we'll use MCAT basically on this. We'll use MCAT, MCAT, MCAT on the slopes. All right, because we're having a temperature change. We're changing the temperature on the side. Here we're on the flats, so we're going to use what we call the heat of fusion. So the mass times the heat of fusion, because it takes energy to heat ice, right? And same thing here, we're going to use what we call heat of vaporization, M times HV. Okay, so on the flats we'll use that. And now, so that's basically the gist, right? During a phase change, use these. During temperature change, use those. Okay, what are those? Well, during water, as we know this value, the specific heat of water, C, is 4.184 from our last lesson, but water also does have a different specific heat when it's ice and when it's gas. Okay, so just keep that in your back pocket. All right, so the HF, all right, so if we are going to melt or freeze, it takes 334 joules, all right? So basically 1 gram of water would need to absorb 334 joules to melt, all right? And then on the other side, so that means so to melt it, it's gonna be positive. When we lose, so if we're gonna freeze it, if we're going from like in the fall, from a liquid to a uh, solid ice, we would say we're gonna lose it, which is minus 334, all right? So basically how you use this, how much would need to be transferred to melt 100 grams of water? Well, if you had 100 grams of water, we don't have a temp change, we just want to figure out how much it would take. Well, take the 100 grams, that's the mass, okay, and then we want to add 3/3 times it by 334, because that's how many, we're just multiplying that, and you'll be left with joules, all right? Heat of vaporization, all right, so it's 2,260 joules per gram, so 1 gram of water would need to absorb 2,260 grams to evaporate, and the other would release, right? So if you're going to cause it to condensation. So how would I do this? How transferred to condense 100 grams of water? So we're going to say Q is equal to MHV. All right. Now here's where you have to go. It's going to be, you're going to condense it. So you're going to release that energy. You're going to cause it to release. So it's going to be negative Okay, absorbing is positive, releasing is negative, so 100 grams times negative 2,260. All right, you guys can do the math there, but basically that's how you use the slopes. Okay, you have to account for the actual phase change. So back at it, here's our graph. Remember on the slopes, you use MCAT. On the flats, you use what we just talked about, right? We do a lab usually where we uh, do this and plot points, and you can see that uh, the temperature plateaus essentially when it's phase changing. All right, so let's just do a problem here. Calculate the heat, and you always want to have this kind of in your back pocket just so you kind of know where you are. So here's where we're at. We are, let's use yellow so we can see it. We're at negative 10. We're about right there, okay? And we want to get there, all right? So to figure out how much heat, Q, I'll go back to this, Q, what I'm going to have to do is I'm going to say, so well, MCAT on the slope, so we're going to say MCAT to get to there, okay, plus I got to go here, so that's going to be heat of fusion, mass times heat of fusion, and then I got to do my temp change there, so it's going to be plus MCAT for H2O, okay? Now when you do this, you have to know where you're at, all right? You have to know that Q here, so it's 1,000 grams, so 1,000 grams, and it's going to be absorbing, so it's going to be positive. The specific heat, so of ice, so this is the ice, this is the phase change, and then this is the water. All right, so let's go back to figure out, well, actually I know it's on the next slide. The specific heat of ice, 2.06. Okay, so 1,000 times 2.06 times, we know that we're going from negative 10 to 0. Okay, so we just don't put negative 10 to 10 because that's part of the liquid. So we're going to say the final temperature is 0, negative, the initial temperature is negative 10. All right, and I say minus 10 degrees Celsius, right? Because that's the initial temperature, plus, okay, 1,000 grams times the heat of fusion, which the heat of fusion is 334. Okay, so I got that part, and I just put brackets there so you guys can see, plus the 1,000 times 4.184, because that's the specific heat of water there, and then we're going, times, ran out of room, times my final temperature is 10, my initial temperature is 0. Because we're here, my initial temperature is 0, my final temperature is 10. Okay, so that is basically how you calculate all that. You just got to figure out where you're on the slopes. Let's pause here and calculate it. Okay, so I got 396,440 joules to move that piece of ice into water. Okay, so that's how much energy is required to do that. Now, when you go to your worksheet, all right, what you need to know is you need to figure out where am I, all right? So how much heat would it take to melt 25 grams of ice? Okay, so to melt, you're going to be losing, all right? So if I'm going to melt 25 grams of ice, I'm going to be going from here to here, all right? So you will just use Q equals M times H V there, all right? Now you're losing, all right? So you got to think about it. Well, is it positive or is it negative? It's going to be positive because when you set this up, you know that like, okay, we're adding heat in, right? If it's coming out of it, that's when it would make it negative, just like in our last problem. Our last problem, we were going up, right, up the slope, so it's going to make it positive. Essentially, the rule of thumb would be this, guys. If you're going down the slope, if you're going down this way, that's when you're going to make your HF or HV negative. If you're going up, that's when it's going to be positive because we're adding that energy in to melt it essentially. Okay. How much heat is required to make 20 grams of ice into water vapor? Okay, so look at number 10 here. Quick, that's the last one. All right, so you figure out where you're at. 20 grams of ice at 0 degrees Celsius into water vapor. Okay, so it's all of ice. So we start essentially here, right? And we want to make it all the way essentially to up here, right? So you got to think about what you want. You can't just start right here because it's not liquid. That point right there, it's liquid. And so we're essentially what we're saying is we gotta do what we need to do. So Q is equal to M times H V F, sorry, plus M cat up the slope plus M times H V. Okay, so that's going to get you all the way from here to here to here. All right, so use this graph to help you know where you are. And that'll do it. So check your answer keys. Let me know if you got questions, guys. Peace out.